Hello guys, so we're correcting the workbook, page 80, 81, and I need you please to copy the answers on your workbook. So this is what you need to do during this lesson. So starting with the first exercise, identify examples of plant stimuli and responses. So you already know that whenever you have a stimulus, you will have a response. And I gave you the easiest examples. For example, you're hungry, that's a stimulus. You eat, that's the response. You're cold, you put a jacket on, so stimulus, response. So what about the plant stimuli? So we're going to start with the gradual one. Example, light. Okay, so this is a stimulus, the easiest one for the plant, or this is what the plant needs, light. So what would the response be? Now, the plant will grow toward the light over many hours. So this is why it's gradual. So the plants will grow toward the light over many hours, as you can see in this example, and you've already seen many of those before. So definitely this is taken fast forwarded, okay? It is not like, you're gonna look at the plant and the plant's gonna grow like that. You're gonna be scared, honestly. So now what about the quick one? Example of a quick one, the touch. Once you touch a plant, well, depending, not every plant, okay? So some plants have this response of, for example, closing, closing on the frog, the example that you saw, like the carnivorous plants, okay? They will react somehow. So they will have a response that is very quick. For example, the Venus flytrap, two-sided, will snapshot to trap an insect. So that's an example. So this is called the Venus flytrap, while there are some different examples of those. So they will close to catch an insect, whatever. Maybe you put your finger, it's going to close. So this is the response that it's going to have. Now this, all the answers that I've got, okay, are taken from the book, page 279. Now, characterize the second exercise. Characterize tropisms. Okay, there are many types of tropisms. Tell whether each response is positive or negative. Now, let's see. They've gave us a little hint, so to know where to put the special tropisms. So, example, they've gave us stimulus is light. So what type of tropism is this? It should be phototropism. Okay, so now we're talking about phototropism to be exact. Now, so tropism is phototropism, the stimulus is light. Now the response, you have two types of responses. You have the positive response and you have the negative response. So when it's towards the stimulus, you call it a positive one, okay? So the stem will grow towards the light. So the light was the stimulus and the stem is growing towards it. So it's a positive stimulus or, a response. What about the roots? The roots are going, towards the ground. So away from the stimulus, away from light, down into the ground. So you call it a negative response. Okay, so you have the stem. Look at the stem in this picture in here. It's growing towards the light, so positive response, and the roots are going downwards, so negative response. So about the touch, so we mentioned the touch in here. It's the stimulus. So what is that tropism called? Thigmotropism. So remember everything that has to do with the touch, okay, the fly trap closing, the little leaves closing on themselves, the little tendrils, wrapping around a stick. So that has to do with the touch. Now what about the drooping? Okay, when I say drooping and it's going, downward like the leaves, okay? So drooping is negative, away from the stick. Okay, they're not going to wrap around the stick. You don't see leaves wrapping around you like hugging. Okay, but the tendrils, they're wrapping around the stick, so you call it a positive response. Okay, as you can see in here again, you have the tendrils. Let's wait for this guy to pass. Thank you so much. And you can see the tendrils wrapping around the sticks. Okay, this is called literally thigmotropism. Okay, so that's a reaction to the stimulus, which is touch. Now, gravitropism. When you say the word gravi, it reminds you of the stimulus gravity. Okay, so this is gravitropism. The response for the stems, let's see, is it positive or negative? Gravity, the stem. Think of the pot when it falls on the ground. Okay, so the stems, negative, away from the gravity that is going downward. Okay, so the stems are going always upward, away from this stimulus. What about the roots? They're going with the gravity downward. Okay, so this is the example. Once you flip a pot, try it if you want. If you don't want your mom to scream at you, fix the pot. But if you want to try this experiment, go ahead. Just flip the pot like that and wait. Okay, you're not going to wait, like the second day and you're going to say, oh my God, let's fix it again. No, you're going to wait like 3 to 4 days to see the stem just tilting. Okay, now depending on the plant, definitely. So as you can see in here, you tilted the pot. The stem is going upward, away from the stimulus, which is going downward, the gravity. This was found page 281 in the book. Now, the third one. Review and give an example of each type of photoperiodism. Okay, please be careful, not phototropism, photoperiodism. Now, long day plants. What about the long day plant? Think of blooming. The flowers will bloom. When I say long day, so they need more light, okay? Then it's less darkness, okay? So long day plants bloom with less than 10 to 12 hours of darkness, so less than 10 hours. Example, carnations. Okay, this is an example of a plant that is called a long day plant, okay? It needs more light, okay? Less darkness, all right? Now, the short day plants, just like we're saying it, short day plant, less light, more darkness, okay? So they require 12 or more hours of darkness to flower, okay? Like the pansita. By the way, in French. Okay, never mind. So we usually give each other on Christmas this plant. Okay, it's kind of red and green, beautiful. So this plant needs more hours of darkness, so less light. It's called a short day plant. Now, when you say the word neutral, it's neither moving forward nor backward. When you talk about the car, on N, neutral, nothing. Okay, it's not moving forward nor backward, so you call it neutral. Neutral, neither positive nor negative, neutral. So the day neutral plant is a plant that flowers unaffected by the number of hours of darkness. So it doesn't care about whether it's a lot of light or a lot of darkness. Example, roses. Okay, so that's an example of a day neutral plant. Doesn't care about the amount of darkness or light. So this is page 80. Let's move to page 81. Page 81. Number 1. Relate the effects of plant hormones. Now you already know that we have, or you've been taught, 4 different plant hormones: auxins, ethylene, gibberellins, and cytokinins. So now each plant hormone has a specific message, okay? A specific message to the plant, like inside the plant. It's doing something to the plant. So it has an effect. So there's something that's gonna show in the plant. Starting with the auxins, what do they do? Auxin's job, it's a hormone, it's a chemical that helps in increasing the plant's growth, okay, toward the light. So as you can see here, it is just tilting the stem in here. It is making it longer towards the light. So that's the job of this hormone called auxin. Now, ethylene, what's that hormone? Ethylene's job is to stimulate ripening. Okay, I've mentioned this in the previous lessons, to become ripe, مستوي, just like it is, okay? So it's stimulating. It is found in every single fruit. Now, and I gave you the example of, adding an apple between the avocados that are totally green. Well, they are green, but they're not ripe, not ready to be eaten. Same thing for the bananas, okay? Same thing for kaki, kharma, no, never mind, so forgot the name. So it's just stimulating the ripening, okay? It's helping in making the food more ripe. So this is why you hear the sentence, when you put a bad apple with, a bunch of good apples, they all become bad. It's like, no, it's not, it is literally like that, okay? So do not think that it's only for humans. When you put a bad friend with other people, he's gonna, affect them negatively. So in this case, ethylene is gonna go from an apple to another and make it more ripe. I'm not saying it destroy it, just making it more ripe until it is totally, not ready. It's not good to be eaten anymore. Now, the gibberellins. Gibberellins are also types of hormones. Now, what do? They increase the rate. When I say the word rate, the speed. So they increase the rate of cell division. So, you were born, or when you were one cell, and then one cell became two, and then four, and then eight, and so on. So that's cell division, okay? Same thing for the plants. They increase the speed, of the cell division. And what else? And elongation. So they become longer. That the word long is inside that word. So they increase the rate of cell division. This is mostly used, with farmers. Okay, this is what they usually use. This hormone, cytokinins or cytokinins. It's a fourth hormone. What does it do as well? It's kind of bunch of it's coming from other hormones as well. It increases the rate of cell division, just like the gibberellin, and it makes by the way, the fruits look better. Okay, they become, they look fresher, even though they're kind of older than the ones that you had before and so on, but they look better. So that's the job of the cytokinins. So increase the rate of cell division, and they can slow aging of flowers and fruits. Okay, and I've put you this little bag in here, this little picture showing that it's sold as well. Okay, it's a bag that you have that contains those types of hormones, and you can add them externally to the plant. Okay, now identify 4 needs for which humans depend on plants. Why do we depend on plants? How do we depend on plants? First thing, and this is the best thing for us, food. Well, I meant to put this guy here. Well, we eat plants. Not only animals eat plants and then we eat the animals, but we also eat plants. One of them is lettuce. Lovely guy. Number 2, fuel. You've learned that in grade 6 about the fuel, the fossil fuel and so on, coming from decayed plants. So that's another need, okay, for us to have plants. Shelter. Example, houses, wooden houses, and before that, those little shelters with plants and those sticks, and wood, definitely trees. Okay, so that's another need. Last one, clothing. You have other plants, but this one is the best, to give an example of clothing. It's cotton, all your shirts, t-shirts, they're made up of cotton, and it's a plant. Okay, so cotton is not found, in the closet. You open it, oh, that's cotton, let's make some. It's a plant, it grows just like this, okay, in front of you. That picture is showing that they pick it up, just like they pick up the cucumbers, they pick up cotton as well, and it's used to make clothing. Explain 2 ways that people can benefit from understanding and using plant responses. Give examples. Now, a plant response, one of them, they gave us the examples. Climbing vines, okay, climbing vines. Now, example of use or benefit. How is it good for us? How are we benefiting? And why do we use those? Now, cucumber plants, instead of, thinking of grapes, cucumber plants that climb, usually you put sticks, long sticks, or the best way, well, I've learned this newly, is to just grab a little rope and put it in the tent, at the top of the tent, and pull it downward and wrap it around a small nail, okay? So the cucumber plant is gonna also wrap around that rope, and it's gonna go longer and longer towards the light. So cucumber plants that climb grow faster. You see, it's much better for the people that are growing cucumbers. They grow faster and they're gonna grow bigger, okay, because they're getting more light. So it's excellent for the people that are growing cucumber plants. Okay, it's excellent for you as a produce, what you're getting from that plant. Now, ripening in response to ethylene. Okay, so for example, a plant response is ripening because of ethylene hormone, okay, or that gas. So example of use or benefit. Bananas, can be picked like this. They can be picked perfectly green and shipped green. You see, they're gaining time. So they're shipped green and then ripe later. So they're using ethylene later on, or just keep them together like that, and they're gonna ripe on their own. Last question. So explain why it would be financially beneficial for a farmer to treat a fruit crop with gibberellin. In other words, why do you think farmers use mostly gibberellin to gain more money? Why? How is it beneficial to them? Well, your answer might be totally right, and I've seen many answers, and they're lovely. Your analysis is great, and very good. Okay, good work. I've put my answer. It can be close to yours. Sorry. So gibberellins increase the rate of cell division. This is what you know about gibberellins. So because they increase the rate of cell division, which means the plant will grow faster, okay? Now, gibberellins also increase the rate of elongation. Not only they're gonna grow faster, but also longer, which means the fruit, imagine that, is gonna grow bigger. And because the fruit is gonna become bigger, so imagine the farmer having a lot of fruit that are really big. Not only they cost more if they're bigger, but they will sell, farmers usually sell their produce, what they have, the product, they sell it by weight, right? Wazn, and how big they look, by the volume. Naturally, bigger fruit weighs more. So bigger fruit grown faster means or translates to more income for a farmer. So it's going to give him more money if its plants are bigger and longer. Because of what? because of the hormone gibberellin. Please correct the homework. Thank you so much, guys.